Hey, so this is a short video about the difference between needs or objectives and things like design requirements and how they're used later to verify and validate different parts of your design after you've created a design. So this should be a reminder that needs refer to the overall project. Things that you've identified pretty early, like we need to engage kids in these activities, or this thing needs to be small enough to store when it's not being used. Now, once you've kind of focused in on a certain thing you're going to design, like we're going to design an activity where kids pick up ducks out of a pond and they scan these toy ducks and see if they have a lucky duck or not, then we can write more specific design requirements. Things that are measurable, like, do 90+% of the parents run it correctly when they haven't been trained at all in it? Is it able to, so instead of saying just small enough to store, we might say it's either flat or it fits within one box that's roughly the size that paper is delivered in. That might be a way of describing it. It's small enough to store if we know we can fit it in one of these boxes that paper is delivered in, plus the rest of it is flat. Now, what's critical here is this idea of these terms verify and validate. When we talk about verification, we're talking about making sure all the design requirements are met. So things that are happening down here at this level on these more specific design requirements. We talk about validation, we're talking about, are the overall objectives met? Ultimately, were kids having fun? Could parents operate it? Was it small enough to store? And all those other broad needs or objectives of the overall project, are they met or not? And there's a really common way that this is represented, this distinction between verification and validation. This is called the Systems Engineering V diagram, and you start on it up here on the far left. So if we're looking over here, this is where very early in the design process is over here. And then you kind of progress down this left half of the V and then back up. And it's acknowledged this is an iterative process, but it's just represented as a V here. And the thing to point out here is this validation plan. This is when you have the whole system design. It links early things. Here it's called concept of operations, but we can think about these also as needs or objectives. And are these needs and objectives over here met when you actually use the system or not? And then down below concept of operations, we see the requirements and things about the design itself. And then on the left half of the V, and on the right half of the V, we're able to see testing and verification that these things are met at a very small level to start, where you're testing little bits and pieces, all the way up to where you're testing the entire system together back against the requirements. Now, because we're at the University of Virginia, we have a better way to show this V. And now I've replaced some of the words with words we've used a little bit more commonly in this class. So we see the project focus. We've determined we're designing this thing that's going to have kids pick up ducks out of a pond and then scan it to see if they have a winning duck. We thought about the needs and objectives of the overall system, these high-level things. We talked about functional and design requirements. And then what's really important here is as you start getting into implementation down further and then testing on the right side of the V, it's how the things on the left side of the V map to the right side of the V. In general, we see this kind of mapping across horizontally, that you take your needs and objectives and you use those to validate your in part of your system validation, as opposed to the design requirements you use more in your system verification. And really more explicitly yet, the design requirements are really used all the way up from unit testing, which means you're just testing little bits and pieces, one thing at a time. Then you integrate a few of those into subsystems and you test those together to see if the requirements are still met or if some new requirements are met that you couldn't test at the unit level. And then when you get the whole system together, again, you're verifying, are the requirements met? And that's distinct from seeing if the actual objectives are met or not. Are kids engaged and are they having fun? We might know that 90% of the time they're getting a correct detection, or 90% of the time this stuff is happening based on the design requirements being met. But does that really mean ultimately that the kids are engaged, that the parents can operate it, and things along those lines? That's what validation is about going back to those root needs and objectives and seeing if they're met. So here's some takeaways from this. Verification means your requirements are met. Validation means that the user's needs are met, or the objectives are met. Verification also is typically performed on small things at first, called unit testing, individual parts, and then into groups of these individual parts, and then on the whole systems with a lot of iteration in between as you find out things may not work initially on some of your testing, so you need to improve them individually first before you start integrating them into the whole system. This makes a lot of sense. You don't want to put everything together, find out it doesn't work, but not be sure why it's not working. So that's really the big points from today about verification and validation and the distinction between those two terms. But I always like to take a step back from the specifics and think about, what does this really mean about an effective designer? What are some behaviors they exhibit that are related to this whole verification validation thing, that are a little bit broader that we can think about? And there are three of those I want to go over today. One is, well, first, an effective designer is able to create functional and design requirements that, if they're all met, then the user's needs are met. This means that if you verify your design, then effectively it's been validated because there's a good connection between the design requirements and the needs or objectives. And in cases where this is not the case, where the design requirements may not capture everything that needs to be captured in order for the user's needs to be met, that might be a case where your verification is fine, but your validation is not successful. Secondly, an effective designer tests each requirement so that changes can be made if those requirements are not met. And you do this on small parts initially, and then on progressively more integrated components, sets of components. You don't wait until the whole thing is integrated until you start testing the requirements. And for this class, and really beyond this class, it's critical that you document these tests. An effective designer is good at documenting the results of their tests and showing how these tests are linked back to requirements. You may require from some prior presentations on prototyping, we said, here are some of these big questions you're going to be asking and trying to answer when you're prototyping. And one is, will it work? And that is ultimately is asking, are the design requirements being met or not? And when you get to a point in where you're testing requirements with your tests, that's when you really it's extra critical that you're documenting the nature of your tests and the findings of those tests. There's a whole guide on the wiki, on the Colab site, that gives you more information about exactly what we want to see you documenting about each prototype, particularly for these prototypes that are being used to compare your system and how it's working against requirements. And now finally, the third thing that about an effective designer that I think this verification validation distinction implies is that an effective designer does validate that the needs are or are not met. And that means going beyond just testing the design requirements and saying, yep, all the design requirements are met, it's good. Yeah, that is necessary, but it's not sufficient to know that the user's needs are met. And in this case, for this class, you're probably not doing some, if any, of these validation tests until you're out doing the playtest. You typically need a full system, a full working prototype being used by actual users to know if their needs are met in order to perform validation. And so when you go and you do those tests with the actual users of it, the kids, it's important to be collecting data and to be using that as an avenue, not just to show what you've done, but actually as part of the design process and the validation part of it.